Hey everybody, this is Larry. This is day 27 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Ooh. We have another hard problem, which we haven't done in a while, maybe a week or so. So let's take advantage of it. Why is this in C++? Uh-oh. Was it previously in C++? Meaning that like I do some crazy things. Hopefully not. We'll see what happens. This, of course, if you're joining us new and you're not familiar with how Leetcode does timeout testing, it used to be that timeout testing was done on in a whole like it ran the test for every it ran the test for every test case, and then it sums up the time it spent on all those cases, which sometimes people record as sum of execution time, right? And as a result, sometimes you might just run into a bad case, or your code might just not be fast enough for it. But supposedly, and I haven't confirmed this yet because I haven't done contest, but I also don't know. I haven't been able to confirm whether they do it for non-contest, that they only do it now on a test case per test case basis. If that's the case, maybe the Python would pass. I don't know. We'll see how it goes. Yeah, today it was just full rest. It's just been I think I've been working too hard trying to like heal my shoulder. I think maybe like too much rehab. Ooh. Maybe just like resting is a little bit good. So I've been kind of spending a little bit. Today I'm resting. That's what I'm trying to say. Yeah, let's get started. This is a hard one. Maybe we need all the time, so we will get started. We have 3666 minimum operations to equalize binary string. You're given a binary string S and an integer K. In one operation, you may choose K different indexes and flip each 0 to 1 and 1 to 0. Return the minimum number of operations required to make all characters in the string equals to 1. If it's not possible, return -1. I don't get it. I mean, n is really big. Isn't it just a math problem, or am I misunderstanding this? Like, it's just breadth first search, right? Isn't it? Huh. My apologies, friends. Get some water. Oh, jeez. My apologies, friends. These are recorded live, as you may or may not know. So you know, these things happen. But yeah, my first intuition is that it's just going to be BFS, right? And the reason why I say that is because, well, the first thing you to note is that n is constant, right? Given an input n, it just doesn't change through the lifetime of the algorithm, right? Or your choices or decisions, right? Like it doesn't get bigger or smaller, it just stays exactly n. The thing that changes is the number of 0 and the number of 1s, and of course they are equal to each other in a way, right? Because, well, number of 0s plus the number of 1s is n. So if you have 1, it defines the other because n is constant. Sorry, give me. So BFS would be my first instinct, and I don't know why I would have. And some of this is honestly maybe like I cheated a little bit in a way, not like actual cheating, because I didn't really look at it, but it was just because like my thing is on C++, and just to be clear, the only reason why I go to C++ is if the Python version is too slow or something. I don't know. Maybe I was doing something else. Maybe that was a red herring. So I don't know, but if it's BFS, it should be pretty straightforward. So that's why I'm a little bit confused. And the reason why I say BFS is because each of these digits are kind of fungible, right? Or maybe put it another way, each of these digits don't really matter, right? Meaning that you want them to be all ones, so you just have all ones, right? Like it doesn't matter if, you know, in the intermediate steps, because they have to be different index. Oh, okay, different indexes. Maybe the different part, it could be tricky because you can't do the same thing more than once. So there is some cases, like an edge case, which we'll go over in a second. But what I mean is that if you have these numbers, right? All these three numbers have 2 zeros and 2 ones, and they are all functionally the same. You still have to get from 2 ones to 4 ones, right, in some way. So that's what I was saying. The different part is interesting, and maybe it makes it like, maybe that's the hard part, is that you have to get these edge cases right, because what it just means is that if you have like k is equal to 5, well, if k is greater than n, well, k cannot be greater than n, but let's just say in an obvious case, k is equal to 4, well, if you have this, you cannot go all 4, right? I mean, that's simple. But even if you have 3, I guess 3 is, I don't know. I mean, 3 you obviously can't you know. I guess I'm just trying to come up with a case where you may accidentally try to do the same number more than once, but maybe that's not even possible. Like, I'm trying to think of it, and maybe they'll come up when I have a wrong answer, is that we have the same indexes, then obviously that's no bueno, right? So it has to be different, and you have to kind of do some math in that regard. Okay, so let's give it a try. I think it's BFS, but maybe, like I said, there may be some weird edge cases that I might be not handling correctly, so yeah. Oh yeah, so 1 is equal to s dot count 1, right? And then now maybe we have, like, you know, like this. Oh man, my water bottle keeps on popping. And this is like BFS stuff, right? So maybe distances is equal to infinity times n, right? And then as BFS, you have distance of 1 is equal to 0, and that's it. And then now, oh, and then of course you have to set up the queue. Right? How do I write this? I mean, you can write this in many ways. While q or length of q is greater than 0 or something. I guess we'll do it this way, right? I don't know why I'm writing it so weirdly today. Not really functional. Okay. Oh, I see. I think now I remember, or I didn't remember, but now I realized that why is that BFS is because, or at least not directly. I might have to think of another cool way to do it. It's because if I just wrote it naively, and I tried to, as you see, because I don't know, today maybe I'm a little bit off, and it happens. If you try to write it naively, this is going to be n squared, because the number of edges is n times k, because for each node you can say, for each, and by nodes I mean like number of ones, you could say, okay, well, like let's say you have k, right? K flips, then now you could say we want to flip k ones to k 0, right? And then you can also do k minus 1 ones to k minus 1 zeros, which, and k, 1 0 to 1k, so some of it cancels out, but you get the idea. And then now you do dot 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 all the way to k zeros to k ones. So these are like, there's k or k plus 1 or whatever number of ways to count these, and therefore if you have so for each state, if you write it naively, it's going to be n times k, and n times k is going to be too slow. So that would definitely time limit exceed it. So maybe that's why I needed the C++, because it's not straightforward BFS. The idea is still BFS though, I believe. We might have to figure out how to be smart, but give me a second. I'm going to do some drawing, hang on. This is an annoying problem. Like, it's one of those annoying problems to implement, because I feel like I know how to do it, but it's just so easy to make mistakes, for me anyway, right? The idea here is, and it's something that I actually talk about from time to time, is this idea of, what did I call it? I mean, I think I call it different things actually, but this idea of frontiering, right? The idea behind a frontier, and I'm going to draw a different but similar problem, is that let's say, because I remember, yeah. Let's say, okay, let's think about, maybe in this problem, it's easier to think about in terms of frontiers, right? But it's basically here, right? Let's say ignore all the k flippings for now, right? Let's just think of a simpler problem, and a simpler reduction is that, and this is just for explanation, is that let's say you, oh man, I always change the color, but I always have to click on like 8 different things. I don't know if the UI changes something on my tool. But let's say, this is your current thing, and let's say for each cell, we are able to go either left or right k steps, right? So it's a little bit similar, but not quite the same because you don't have to do flips and parity and stuff like that, right? So then now that means that from here, you can go, let's just say this far, right? And then, and then you're also, so that means that if you do a BFS kind of thing, in one step, you can go here, here, dot, 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 right? Then now on your next BFS, maybe this is your next stop, right? Next step. And then here, you may also try to do a BFS, and maybe it'll look like this, right? I mean, because you can move k steps away, so you're able to go here, 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 right? And of course, in the same way, this is going to be n times k, right? Because we have n of these red boxes. Each of these do technically 2 times k operations, but whatever, right? So O of n times k, right? But the thing that you notice is that, well, what happens? Well, you know that some steps are not possible, right? And what I mean by that is that if you kind of match these things up, let me change the color again. If you match these things up, you know that here, it's definitely a subset of here that we've already done. And here on this side is a subset of all these things that we've already done, right? So then in that regard, we don't even have to look, we should not even have to consider them. If we have, we have to figure out a way to have a data structure and all these things, right? But right now, if you just look at it that way, then now this is no longer O times n times k, right? Or O of n times k, I don't know why I said. Because now, each thing can only really extend in 2 different ways, right? Because almost like, if you could think about it like maybe in a sliding window kind of way, I don't think it's quite that, but maybe it helps you visualize, is that if you slide this to this, then now only one new thing comes in, right? And everything overlaps. So that's kind of the idea of how I attack this problem, because now, then this is going to be O of n, right? I mean, of course, there is one initial k, just like in sliding window, but it's going to be O of n because every incremental one. So you can, technically, I think it's O of n plus k, if you really want to be precise, but O of n-ish, right? Because k is less than n anyway. So that's the kind of the idea that I want to do. But of course, it's easier said than done. And of course, for this problem, it's a little bit different than that, right? There's some stuff about parity, and this we can actually like write out a little bit, right? Because this means that this is plus k1s. This means is plus k minus 2 ones, because one of them cancels out, right? And then now you have k minus 2. And then all the way dot 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 to minus k1s, right? And then again, yeah. So that's kind of one of the things, right? And then what I mean by parity is that if k is even, right? Say k is even, so let's just say is equal to 6, for example, as an example. Then now it's going to be plus 6, plus 4, plus 2, plus 0, right? Or plus minus 0, minus 2, minus 4, minus 6, right? But noting that every cell is, doing this means that it's not possible. So if you're starting number ones, I don't know if I have allergies or something. I'm like really struggling with the breathing today. Let me get more water. But yeah, but what it means with respect to parity, and what I was pointing out is that if you start with an odd number, you cannot get to a even number, and if you're an even number, you cannot get to an odd number, right? And of course, if 8k is odd, then there's no such constraints, because let's say this is 3 because I'm lazy. So there's 3 plus 1 minus 1. Oops, I just wrote it wrong. minus 3, right? And I don't know if this matters, but this frontiering thing is just about trying to figure out how to implement it correctly. And it is very hard because the thing is that you cannot even put a for loop here, right? Well, it's not a good, not in a way that's k, right? Because what we want to write is maybe for k and if ck for current k is equal to like negative k all the way to k plus 2, maybe this is plus 1 or something. But you get the point. This is going to be even if you do the if statement, and even if this if statement is false, for all of them is still, well, not all of them because it has to include something, but you get the idea is that it will still be n times k because just having this for loop existing makes it n times k, and n is equal to 10 to the 5th. It's going to be too slow. So you have to do this in a smart way such that you're able to do this frontier thing. And then there's some really edge cases with like like, okay, let's say you have 1 1, you have minus 3, technically minus 3 in this case doesn't exist, but you have plus 1 and all these things. I don't know, maybe there is no that case. So all right, well, we'll see what happens. I'm just gonna implement this a little bit still on the naive dumb side. I got a second order, by the way, and it's still also doing the popping, but yeah, let's play around, right? And maybe for this one, I'm going to have 2 frontiers, one for even and one for odd, so that, and I don't know how much of it is just going to be, I don't know how much of it we'll see, right? And I'm trying to think, it's all implementation at this point, but I'm also, I said this is O of n, which is maybe true, but it can also be n log n, by the way. So maybe I'm lying on that, depending on how I implement it. Because instead of doing O of 1 lookups on the frontiering finding, maybe we could do O of log n, and then now it's O of n log n, which is fine still. But maybe that's why I was doing timeout on Python. But we'll see, right? So now we're going to now, right? So and one thing to keep in mind also, though, with this parity thing is that they all have the same parity, right? Meaning that if you start with even and you go to even, it's all of them are going to be even because they're all separated by 2. So that means that you only have to check one thing, right? One frontier. I want to write something like this, and maybe it's too slow, but I don't want to prematurely optimize. We can, if this times out, we'll prematurely optimize. Well, in that case, it wouldn't be premature, but we'll just do an optimization, right? So this. Yeah, maybe we'll do something like this. But when we move it, whatever, I'll keep it here for now, right? You could write this in a number of ways. I'm just lazy. Okay. Right. Okay. So then now, if now plus k next frontier maybe is equal to odds. Otherwise, remember that this is a reference assignment, right? Not a value assignment. And what I mean by that is just that it's like a pointer, if you will. So, so this actually both manipulates the original and also just easier to type. Then now we can do it, right? Now we can say, so maybe lower bound is equal to now minus k. I want to say is this, like you want to say something like this, but it's not, or 0, but so that it cannot go to negative. But that's technically not true, because it can also be 1 if the next thing is odd. So maybe I'll just put it this way then, right? Fine. And then this, of course, actually, this is actually annoying to write, but maybe that's fine. Now I'm gonna do this in a very silly way. I'm not gonna lie, but yeah, I think that's fine, right? Actually, maybe this is fine. I don't even need the upper bound if I'm gonna do it in a dumb way. But yeah, otherwise, if this is even, then we do the, I guess just lower bound or 1, right? Oh no, the other way around. Well, now this is very awkward. Whatever, we'll just write this way. It's an extra max function. It doesn't. We don't have to optimize out the max. It's fine. Then no, right? And now we want to go from lower bound to upper bound, which is maybe n minus k. Oh, sorry. Now plus k, right? But the reason why I don't write it out, and maybe I should, I don't know. Yeah, maybe I'll write it out, actually. Because I think I actually don't need to, bound this one the way that I'm going to write it. What I was going to write is something like this. So it's while true. How do I, so we have next frontier dot bisect left of the lower bound, right? Yeah, you could do that, maybe, right? So if index is great, that means we ran out of numbers, then or is greater than upper bound, then we just break, right? That means we're done, because we're, and what I'm doing now, maybe next it'll be clear, is that we're basically, I'm doing a lot of binary search, which maybe is not optimal, but also I think it actually doesn't degrade the complexity too much. Again, don't prematurely optimize. I want to go for correctness first, and the reason is because for each number, you are going to, each number in each of the frontier, you are going to binary search at most once, because after once, you are going to remove it. So item is equal to this, but we also next frontier dot remove item, right? So we remove it, and then now we do some processing, which is to say q dot append item, and distances of item is equal to distances of was it ones? Oh no, now plus 1, right? Because you made one move, and then maybe we can also write if item is equal to n, then we just return distances of item, and that's early termination. Otherwise, we return -1, and we should be good. Yeah, and actually we don't. So one thing that I was thinking about is like having this. You know, when you write BFS, you have to check whether you process the number already. But here, you only process numbers that you remove. So I think you should not need that, but I could be wrong, right? Okay, we got one answer right. So that's good. Apparently, we just return -1 for everything, which so will get you correct some of the times. That's obviously not great, but we'll play around. Okay, so you start with 2. I mean, it may just be something silly with the implementation wise, so we'll see. I'm going to start with 2. K is equal to 1. So you process 0, 1. Do I not process 3? Oh, I am dumb because this doesn't have n in it. No, I think that's fine actually. I think we just has to process it. Yeah, I'm actually just off by 1 on this because for an array of n elements, you want the valid states to be 0 to n inclusive, and that's n plus 1 numbers, right? Okay. Oh, that means I have to assign some stuff correctly, like this one, for example, that I just kind of got lazy about. I think that's it, really, maybe. So it looks okay. I do worry about timeout just because, well, apparently it's an issue that may be in the past, but let's YOLO submit it. We'll see what happens. If it times out, at least that means we're probably correct in terms of correctness, but you know, maybe not. I just never checked for the initial, I suppose, because I only checked it. I usually write this here as well, but I guess I just forgot because I have this here, so then now it does 2 steps. But yeah, I mean, that's just silly. Okay, fine. I mean, that's just a silly one. I was thinking more about correctness about this part, so I kind of got a little bit lazy there. This is an obvious case that I should not be getting a wrong answer on, to be honest. Okay, this is more interesting. Huh. It is, and also why? Maybe it's another base case. Why did I put 2? It starts at 0. Zero plus 2 is even, right? So it goes evens. Lower bound. I mean, lower bound just goes to. I need to remove itself. I think that's. Oh, but it should still find the quickest one, right? I do need to remove itself though from odds and even, because then it might go back to it again. Though it will never be the quickest move. So I don't know if that is the thing. Why is it giving me 2? Alright, well, let's just print it again, I guess. Let's also print the frontier. Okay. So I hope it's just a silly mistake, because I don't really understand how I would get it wrong, necessarily. But... because if I did, then I would just fix it. Okay, I mean, this is, like I said, this is wrong, but... why is it returning 2? So it's 0. Distance. Oh, it was that reason. I see it, and that's just sloppy. I mean, it was the reason I said about like the initial thing, because we update the distance when it queues itself, so that when this happens, it uses the updated value. That is just sloppy. But it is what it is. That is just okay. Yeah. Okay. Honestly, though, I was talking about so much about correctness. I was thinking more about the overall. Oh yeah, I think this is the case that I was talking about. But even though I thought about it, but yeah, I was focusing on the correctness and in terms of the complexity and implementation, that I didn't really think about the problem itself, because these are very problem-y edge cases, and that is just sloppy by me. But yeah, but this is the one that I was, because honestly, this was the one that I was worried about, at least in terms of correctness of implementation. So I was focused on this part of the implementation, which we didn't make any changes yet. It just that it turns out that it was this part that was wrong. So where's the other if statement? Oh yeah. So it was just this part that we've been fixing so far, but this is what I worried about, right? Because then now, the lower bound. What is the lower bound? And honestly, I didn't know about this case. We even literally brought it up. I was just too lazy to think about it, but that's not an excuse. Because even if I was too lazy to think about it, I could just put it in the test case. I think I just forgot about it by the time I implemented it. But yeah, so okay, you start with one of them. It thinks that you could go to 0 or 2, which is true. No. You cannot go to 0, but it can go to 2. Why can it not go to 0? 0 would imply 0 would imply that we have, okay, so we'll write it out, right? So we have 1 ones, 0 would imply -1 ones, which means that we turn 2 ones to 2 zeros, and 1 zeros, 2 1 ones, right? And of course we don't have 2 ones to turn, so yeah. I actually didn't know about this case, but I was just lazy and I couldn't figure out. Well, it's not that I couldn't figure out, it's just that I was too lazy to figure it out, I guess. Sorry, friends. It's been disappointing, but you know, I can't. Okay, whatever. Sorry, friends. I'm just like really tired today, and maybe I was trying to take some shortcuts. Yeah. So now we have to factor this in, right? How do I? Is it a lower bound issue or an upper bound issue, right? And can we do it in a consistent way, right? Because here we just track the lower bounds. Maybe I'll do okay, it's fine. Okay, so then now, now is the number of ones. So then now is the number of ones. That means that we, at most, we can do now ones to now zeros, right? So you have something like min of now and k. So that's number of ones to zeros, and minus zeros to ones, right? Zeros to 1 is going to be something like this. So this is the number of ones, or the number of zeros. And this is the delta, right? So max delta subtract, I think, something like this. Well, this is just max delta, and then the signs we can fix later. Maybe? It's something like this. And then we have to do it for the plus, which I think hopefully it is just this. That doesn't make sense though, because, or at least it'll mess up the min, right? So if min is negative, then you definitely mess that up. Okay, so the lower bound, this is tough. I have to think about it. It's tough because I'm lazy and restless right now, and I think this formula is hard to deparse. I think I can just do something like this actually. But also speaks to, like, yeah, that's why you don't want code duplication, because now I have to make these changes in like 5 places. Something like this. Did I put this in there? Just make sure that I get this first. I mean, okay, so actually, I mean, that's maybe fine. I want to print out, I want to at least fix this first before going back, but so the lower bound is 1, which is kind of wrong, but it's kind of wrong because we're going from 1. Like, this should be a even number is my point. But maybe if we look at the correct next frontier is fine. I don't know. This feels very sketch. Why is this 1? So the max delta, this is going to be 1. So that means that this is 1 minus is it? So you have 2 zeros. So this could be minus. I mean, this is 1 as well. So max delta is 0, which would include itself. I guess it wouldn't make sense for this max delta to be -1. So maybe that's fine. I don't know. Let's take a look at case 1 and then see. So at 2, I guess this is just wrong then, because should not be just 2, 2. So okay, so at 2, we have 2 1s, but we can only do 1. And we have, maybe this is just wrong. So okay, so let's say you have, okay, so if I have enough 1s, then it's just k. What if you only have 1 1? Then now max delta, well, it's going to be not enough, right? Which is what this is saying. But if you have 1 thing, this is the number of zeros. This is wrong. This is right. It's not k, n minus now, it is k minus now, because that's the number of 1s. Yeah. Oh, sorry, number of zeros. But then now this is wrong on the max side. Okay, the max side I wasn't super sure about anyway, because I was just adding negative stuff to it. And I think now that we changed the formula, it doesn't really make sense. Yeah, then now the upper bound is going to be the number of zeros, right? And then now it's k minus now. The reason is because you can't just negative that, I think. Maybe I'm wrong on that one, actually. Oh, actually, maybe this is the number of... Yeah, maybe actually I don't need this. I think using the same... No. I mean, the plus is fine. I think this is technically minus because it's of the double negative or something. But, maybe not. Yeah, the upper bound is not right. I think that's what this is telling me. Okay, so you start at 0. Max delta, you have... Okay, I think I just need to write it down in terms of... Because this is 1-centric, right? So, okay. One's going to zeros. Okay, so then now 0 is going to 1 is going to be the max thing, right? So you have, let's just write it out. Zeros is equal to k minus, no, this, and that's why this is wrong, actually. Okay, I see already. Okay, so this is the number of 1s. And then... Maybe something like this. Maybe that's why that's wrong. Yeah, well, I mean, that's not true. This just looks weird, but okay. Because this is the number of zeros minus the number of ones. Is this right? Oh yeah, right, yeah. Well, this is this minus this, I think, now. Yeah. Okay. So I wasn't, yeah, okay. And you could write it, maybe I'll just write out zeros here, because now is the number of ones. It's just easy to see. Okay, oops. But yeah, as you can see, I'm just playing around with the bounds. I don't know how I feel about it, and maybe it's still wrong. So we'll see how. I'm just lazy, so I'm gonna submit. Okay. Expected 4. I guess this is where the frontier. I was worried that it would do something like this, but I was hoping it wouldn't. Yeah, this is such a mess now. Sorry, fam. But yeah, that's the thing with this lower bound, upper bound thing, is that you might not get to it directly. Okay, so 0 goes to 3, but 0 also goes to 1 for some reason, right? Because we record the bounds from 1 to 3, which is actually not right. Because I was actually assuming that you can go from the, yeah, this is clearly not right because you cannot even stay at 0. So the lower bound is actually wrong. Because the lower bound, I just assumed that, well, I was thinking that you could just stay at the number, but you can't even stay at the number. Because I was thinking that the next number, yeah, I don't know. It's just wrong. Okay. So that means that I have to fix the lower bound. How do I fix the lower bound? Okay, so we have 0. This should be 0. Right? This is the number, yeah, this is 0 for 0 ones. This is, that means that we are gonna do a -3. But the thing is that there is this max 1 thing. I think that's why it's showing up as 1. No, but that doesn't even make sense, right? So now is 0. But the lower bound, it's not. I mean, this thing is never going to be negative. So that means that this is always going to be wrong, right? So we have to figure out how to do the lower bound. I'm doing the lower bound wrong. And that also means that we're probably doing the upper bound wrong in the opposite way. But, alright, I have to think about how to do the lower bound, right? So, because I was thinking about max delta, but maybe that's not the right way to think about it, and just kind of do the maths. So we have either, let's see, we have either now minus k is the lower bound, or now we subtract out so 1 to 0 is going to be 0 minus 0s to 1, which is going to be k minus now, so that's going to be -3. It is -3, 0s to 1. So you're forced to take a +3, but I'm still kind of, How am I thinking about this? Am I doing this? I mean, I'm trying to think about the formula, right? 1, 2, maybe this is not, a lot of this min stuff, maybe it's not necessary. So, okay, so we have max. Let's say k is, ow, hit my knee. Let's say we're going from 1 to 0. So then in this case, the max, or the min delta maybe, we have to figure out the min delta is going to be Is 0 to 1? Yeah. Oh, 0 to 1. All right, let me think about it. This is so hard to think about without paper. Maybe I should just get out paper a bit. Okay, so basically, on one hand, we get I think what I'm trying to do now is reset myself a little bit and try to rephrase it, right? So maybe instead of this min max delta thing, and in terms of figure lower bound, we go, okay, use the most zeros that we get, so we get the fewest ones. Or maybe another way is, okay, right, lower bound is what is the fewest ones we can get, right? That's really what we're asking. And here in theory, you know, so that we get the lowest ones, right? Okay. And then now we know that we make either k 1 minus 1 zeros or now 1 minus zeros, right? If it's smaller. And this one we kind of had it correct, and now we're just adding stuff to it. And in this case, there's k minus now zeros to ones, right? So that means that now, and that's where I went wrong, is that I have these like min things that I thought maybe I could do, but it's supposed to be combined. Because now then the actual delta would be now minus k minus now. Right? Yeah. Except for now is capped by min, I think. So maybe I would write like ones to move is equal to now, right? And then we have either k moves. I'm just going to if move them out, right? So now if k is greater than equal to now, then we can just do all of them up to a point. Maybe we don't need this. I just want to. Okay. In this case, we have lower bound is equal to. We just use all of them. And we always said we have enough of them, so that means it's going to be now minus, because the new lower bound, this is the delta, so it's actually this minus k minus, no, this is just k minus, oh, now minus k. I forgot that this is this case, right? Because that means that you can use all of them, right? Otherwise, actually, is this true? No, I got this wrong. If we have enough ones, if we do not, then lower bound is equal to so the delta, this is the delta, right? Delta is equal to now minus k minus now, so it's going to be now minus delta. Yeah. And then we could actually get rid of this. You can actually even get rid of this, really, honestly. Well, not this. Get rid of this and this. This is the upper bound is probably still wrong, but I just want to kind of run it real quick, at least for this case, so then we can see, right? Because there's no way that the upper bound, like by the argument of symmetry, and your code should look kind of symmetric if you expect symmetry in both directions, roughly speaking, anyway. Because yeah, so I think this looks better, because then now the 0 has the right bound, but of course 3 going back to 0 makes sense. But 3 staying at 3 doesn't make sense, which is what we're trying to fix now anyway, because that's the issue of the upper bound. So let's go. I think one thing that I do worry about is that these bounds are not contiguous, but we'll see how it goes. Or like the search space that we're doing, but I think it should be, but I could be wrong. I've been wrong a lot today. Right? Alright, so 0 is equal to this, but now that we have this, then now if 0 is greater than equal to k, then upper bound is just equal to now plus k, else delta is equal to z minus k minus z, and then upper bound is equal to 9 now plus delta. I think that should be good. Okay, not gonna lie, I'm a little bit lazy, so I'm just gonna YOLO it. Okay, and I think the funny thing is that I maintain that most of our ideas are right, but also, as I suspect, this was a mess to kind of implement. Maybe it's like if you ask me to do a postmortem, I think it's just because I was going on gut, right? And what I mean by that is that you saw me did a lot of formulas here instead of kind of writing them out one by one. And when I wrote them out one by one, we got it right on the first time we kind of write everything out, right? But it's just that I was trying too much on gut, and maybe I felt a similar problem that was in this one, and that's how I got the formulas. And so, and the reason why I do it is because I'm right more often than not, because if I'm wrong a lot, then I'll just stop doing it. But it didn't work for this problem, and I think I just got a little bit things fuzzled, confused, whatever. And this is why I also always talk about visualization, right? Because when you're able to visualize, you are able to kind of come along to the right answer. It's just that today I was just lazy. And I say that a lot, especially today, in that nothing we did was impossible, right? It's just that when I say I'm lazy, it's because I probably should have done this first. And in one of those lazy irony, right? If I had done this first to begin with, I would have done a lot faster, because then I wouldn't have to debug. I wouldn't have to look in that, all these things. But I was just lazy, and I was like, I'm just going on gut because I'm lazy. I'm gonna do it fast, And I was very wrong. Okay, I am gonna spend a couple of minutes to go over this really quickly. I think, the core idea, like I said, is that it's gonna be BFS, but you have this idea of I call it trains and stuff, but this idea of frontier on the left and on the right. I mean, we already drew out the picture, so that part I'm not going to go over that much. I did have a couple of wrong answers on just silliness on here. But then the hard part for me anyway, clearly, was just how, even though we had the idea about the upper bound and the lower bound, I just didn't do the math, right? I was trying to do everything in one statement, one sentence, whatever you want to call it. But I was just wrong, right? And now if you see out the if statement, it's pretty straightforward, because the if statements come from, writing the problem out the way that I want to interpret it. So nothing impossible, but just annoyingly dumb for me anyway. And as you can see, of course, that, I don't know why we go C++ actually. What was my old code? Let me take a look at what I did before. I mean, we did optimize min and max a little bit. I guess I did the same thing, but oh yeah, we go to the next index and move. I was actually thinking about this as well, but maybe not this stuff. I don't know what this stuff is about, but because I was worried about some stuffs, but still faster somehow. So I don't know. I mean, one reason why this is fast, this is slower, is because I do a bisect every time, because I was lazy. I was just bisecting and then we move. While here we just increment the index, so that's slightly faster, because we're not doing a bisection. We're just going an index lookup, which is still log n, I think, but a faster log n probably. But yeah, so what's the complexity? Just to go over it, right? Well, this loop happens once per index, and here, even though there's an inner loop, each number can only be removed once. So this is going to be log n. So everything is n log n. And that's it. Let me know what you think. Thanks for watching. If this is not a good video, maybe my previous video is a little bit better, but I think I like the code that I did better today in terms of the end result, not necessarily the intermediate. I mean, I got way fewer answers. Sorry, I got way fewer wrong answers last time, but I just went into time limit exceeded stuff, right? So I don't know. Yeah. Oh yeah, that's right, because you have this thing. Anyway, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to your mental health. I will see y'all later and take care. Bye bye.